Most people in data can tell you what machine learning is. Very few can tell you what it looked like before any fancier buzzwords. When you were building predictive models for the US Navy SEALs or catching fraud at scale before AI was something companies put on their websites, Dean Abbott has been doing this for nearly 4 decades. He's the founder of Abbott Analytics, a published author, a former visiting scholar at UVA Darden, and one of those rare people who've been deep enough in the field long enough to know the reality of it. I'm Clara, your host at Conversations in Data by Techsalerator, and today we're going back to the basics with one of the people who helped write them. Dean, thank you so much for joining me today. I'm so happy to have you on.
It's so good to be here. I appreciate you asking.
Absolutely. Thank you so much again. And we're going to get into the thick of it today. So again, thanks for joining and let's get it started.
Sounds good. I look forward to it. You
Absolutely.
ask anything you want.
Okay. Sounds good. Deal. I wanted to start at the beginning from the scratch, right? So you've been in this field before anyone called it data science. So what were you actually doing in the early days and how did you end up here doing so much?
In the, 40 years ago, when my first job, I was in graduate school at the University of Virginia, and I was just looking for some work while I was still in school. And a company that was doing aerospace engineering, of all things, contacted me. And the president of that company was a man named Roger Barron, who neural network books described him as having the only commercially successful neural network company in the 70s. And he sold that company and started this small boutique consulting company. And so when he brought me on, I was doing applied mathematics at UVA, and I was doing kind of fancy algorithms to do smart bomb technology, the early smart bomb days. So we were doing things like guiding missiles, like trying to change trajectories to hit targets better. And the mathematics is very complex. So the secret sauce of the company, though, was taking those kinds of guidance actions and encoding them in mathematics. Like with these neural networks, we use something called polynomial networks. And that was really the cool innovation, is to spend all this time simulating, and now let's create a form of it which is parsimonious, easy to run in real time. And we did this for the Navy, and I spent years doing that. Statistical learning, as it was called, because it was before it was called data science, before it was called data mining. It was maybe referred to as statistical learning. That was such an interesting idea, dedicated my career to it. That's what I wanted to do, because that was the funnest part. And frankly, everybody in the company did the same thing. There are multiple people in that company who went off and formed their own companies that became data science companies because of that formative experience with the company.
Wow.
Because the algorithms don't really care what the data is. It could be missile guidance, it could be a marketing campaign, it could be churn, it could be fraud detection. The data is just rows and columns, and the math works regardless of the type of problem you're solving.
I really like that you said about how it clicked for you that that's what you wanted to do. And it's so interesting to have that career click. I always pull things. Of course, I talk about data. I work for a data company, but I always pull things to the HR side, the recruiting side, the human part of things. And I think it's so fascinating when you're exploring a job that you have and then it clicks to you like, oh, I really like doing this and I want to do this for the rest of my life. Thanks for sharing that with me.
Sure.
But yeah, so you were talking a little bit more about the Navy SEALs and things like that. You worked on government and defense contracts early on, like you were saying, including, a multi-year contract with the Navy SEALs. What can you share about that and what did it teach you about applying analytics in high-stake environments?
Yeah, I think the fortunate thing is by the time I started doing that consulting, it was later in my career, so it was in the 2000s.
Mhm.
And so I understood a lot more about the craft of doing analytics. I was brought on for a multi-year project. It was here in San Diego at the amphibious base. And it was in part because I had a clearance still, so I was able to look at classified data, and also because I was local, because all that work had to be done locally. So, and they were using a specific software product that I knew very well. There's one of my books was on that software product. So it was a really great combination of things. So that's what brought me there. The thing that was fascinating about that work is that was in the thousands was at a stage where two things were happening. The Navy SEALs were being used more extensively in operations around the world. And then
Mhm.
the Navy had just changed the way they, just the career paths. And without going into all the Navy jargon on it, there was a change there. So they started recruiting more high schoolers. And so high schoolers going straight into the SEAL program, the SEAL training program, and they were having really poor success rates. Now, the SEALs were always very difficult. Once you class up, as they say, and start a class to go through all the three phases of training, there is maybe about 25% of them would make it through. And most of those who failed in the first 3 weeks, because week three was what they call hell week, where they're up for days, no sleep, just running these guys ragged. I mean, no sleep, you're in the cold water, you're carrying logs, you're getting yelled at and screamed at all the time. And that's where guys will what they call ring out. There's a bell literally in what they call the grinder, this rectangular area that they would go to, and they'd ring the bell because they had to dismiss themselves. They were never told you were done. You have to be you have to self-select. So what we're trying to do is predict what characteristics in those high schoolers will be best, most associated with success after Hell Week. And that was the fascinating thing because there are physical parts to it, which were very interesting because you have
Mhm.
to qualify, you have to be able to do so many push-ups, sit-ups, pull-ups, and fast enough and swim fast enough. But you could actually measure one of the interesting things that we discovered, you could actually quantify how many more push-ups, pull-ups, sit-ups, etc. an 18-year-old needs to be able to do compared to a 22-year-old because there is such stress. Everyone is pushed to the limit. And there's such stress when for young men who are 18, you can imagine they're still I mean, they're out of high school, so the maturity level is not as high. And so when you're a little older, it's easier to handle all the stress. So you could measure that and say, well, we need them to be more physically qualified and fit. We also discovered what kinds of sports were most beneficial for SEALs to have excelled at. And it wasn't like football, baseball, basketball, the typical sports. It was more the individual kind of oddball sports like wrestling and mixed martial arts, and those that had higher success rates. And you could also see that it wasn't the superstars that typically succeeded. One of the things when I talk to instructors, one of the things they said is everybody hits the wall. One of the things you have to learn how to do is how to overcome hitting the wall. So if you're the kind of guy who was always successful, it was difficult for you. The
Mhm.
ones who had failed at some point in their life and had to overcome the failure to succeed, those are the ones that kind of grit and persistence. That's what they really needed in order to get through training. So those are some of the things that were interesting that we found.
Yeah, that is so interesting. And we've been chatting for 5 minutes, and I need to read your book. I'm already fully convinced to read any book, anything you've ever written. Of course, I did a lot of research on you, but I haven't read your books yet. And that's so, so interesting. And also the fact that you can measure something that sometimes can be so subjective, right? So you don't know exactly if this person is going to succeed or not, but you can analyze. You can definitely have a poll and look at it and look at the stats of success or not and see what are the metrics that are driving it. Definitely. But sometimes, people beat the odds, and that's so, so fun to see.
It is fun to see. And that kind of effect, that's one of the things we were asked about in particular, as wanted, there was a movie in the US called, I forget what it was called, but it was about Notre Dame and this guy named Rudy. I think the movie was called Rudy, where this
Right.
guy who wasn't recruited, but he just gutted it out and he made the team. He didn't play until the last game they put him in as like one of those success stories of somebody who just worked really hard at it. And they said, we
Yeah.
don't want to miss the Rudies. The problem, like you said, sometimes that works. Most of the time it doesn't. And one of the decisions you have to make as a business or operationally is, do you try to find everyone who will succeed? Or are you willing to miss some of those because on not just on average, but the vast majority of the time, these other characteristics are the most associated with success. And that's where business, and we may get a chance to talk about business metrics. That is so critical for the analyst to understand what the trade-offs the business cares most about so that you build the models and assess how good the models are according to what the business really cares about.
Let's talk a little bit more about Abbott Analytics. You founded it in 1999 and you're still running it. What
Mhm.
made you go independent from what you were doing before? And is there a project for those from those early years that still shapes how you think and do your work today?
Yeah, I started Abbott Analytics then because I really wanted to always do the kinds of analytics kinds of projects that we're discussing here. Use data to and use machine learning style algorithms to solve these problems. And the jobs I had over the years, the first job was fantastic, but then I was in a couple other jobs that were really good, really interesting, but it was part time doing the analytics work. I would have to do other things along the way as well. So at that point, I decided, let me try to go on my own. Then I can really control my own destiny. Now, I don't come from an entrepreneurial background. And so that was the biggest adjustment is trying to build my own funnel. And so the funny thing is all of my first clients were former employers. So, because I didn't burn bridges, and so I left companies, so I went back and when they found out I was independent, they said, "Do you have time? This is something we've been wanting to do." So I would do a bunch of jobs with them until I built up enough history to be able to market myself a little bit better as an independent consultant. There were so many projects in those early days, but probably the most enjoyable part of what I did is in addition to the consulting, I also did a lot of teaching, which that started my more public speaking career. And that's
Hmm.
really how the Applied Predictive Analytics book came about. Is I was in San Diego, a colleague who was building courses, mining courses, came out and we were talking, and he really wanted to create a new kind of boot camp, 2 day, 4 day uh series. And so we're sitting by his pool at the hotel he's at in San Diego, and we designed this series of courses that in 2000.
Wow.
And I did that for the next really 14 years until I was with Smarter HQ, didn't have time for that anymore. But it was fascinating because you learn, and you probably understand this too, you learn more about a topic when you have to teach it because you should always know, and I'm making up the number, like 5 times more about the subject you're talking about than you're ever going to express because you're going to get questions. And also, understanding the greater depth and breadth helps you with the nuance about those concepts. So, I mean, just applying all the research, trying to figure out how best to communicate the ideas, and getting all those questions from attendees, which are so good, so insightful, and people ask questions I never thought about before. It's like, okay, that's a good question. How would I answer that? And so you do that over years and years, and it just helps you understand the field much better. So that was with Abbott Analytics, that was a critical thing as well as doing the teaching and training.
Yeah, teaching is fascinating. Anyways, talking a little bit more about the book, Applied Predictive Analytics, right? So, still one of the clearest books in the fields. If you had to distill the core idea into one single paragraph, what is the book actually about?
Yeah, the book tries to identify the most important technical principles related to predictive analytics and machine learning, but just as importantly, how to apply those principles in a practical way to solve the business problems we try to solve. So, a core part of the book is the framework. How do you go about solving these problems? What are the steps you go through? And the biggest miss that most companies have that I spent a lot of time in the book talking about is defining the problem you're trying to solve.
Hmm.
Because so many projects fail because the problem is not clearly defined, or the analyst sometimes. Oh, here's the to me the funnest part about all this. I've had this happen many times on projects where a stakeholder will ask me, Dean, I want you to apply some that machine learning stuff to this problem. So here's some data, and just do your magic, whatever you do to make successful models. And I tell them, the thing is, these algorithms are not intelligent. It's just math. And all the math does is exactly what we tell it to do. And so the problem is if we don't define it, it's not magic. We need to define what the data is. We need to define what we're trying to predict. For example, let's say you're building a model to predict churn. and where churn is, when a consumer, let's say you're a credit card company, and when a consumer leaves the credit card company, you want to make sure you keep your clients because it's so costly to acquire new customers. But what does churn mean? Because this is you've got a column in your data that labels, oh, this consumer churned, this one did not, this one churned, this one did not. So, and that's all the algorithm has to go on, is how you label it. Now, is churn when they actually leave, when they say I canceled my card, or it's churn when their spend, which has been $1,000 a month, now is like $200 or
Yes.
$300, something like that. And that could be the leading indicator for the credit card company saying, let's do it when they've dropped 75% of their average spend over the last 6 months. That is a red flag. We want to operate against that. And we need to predict far enough in the future so that you can actually do something about it. So when you're defining churn in that context, and the real definition would be a label for a churner is a consumer whose spending dropped 75%, and you're taking the state of that consumer 3 months prior to when they had that drop so that we can forecast when that's going to happen and then do something about it to try to correct that situation. The analyst doesn't know that stuff usually. Usually the analysts, I mean, they're geeks, they know the data. They know how to use data, but they don't know what the business cares about most of all. So this is a conversation and a back and forth to try to unravel what's most important to the business. That takes a lot of hard work,
Mhm.
and it takes time, just calendar time or clock time for that discussion to take place to unravel what they really want. That's just one example that's in the book.
I know. And I feel like we could stay in this one example for probably over an hour. There's just so much to unpack there, but um, I agree in the importance of finding the problem. You need to define the problem, right? And that's what we do in all data sharp entities. So Techsalerator got acquired last year by data sharp. Now we're a part of a group. Things are going so well. We hire data analytics people, data consultants, data engineers, data. And all these people work together, like you were saying. The data and analytics people, sometimes they don't know the business perspective. That's what we do. We solve data problems for them as well. But anyways, you've said a million times that, data is king more than the algorithms. In the world obsessed with which model to use, what does that principle actually look like in practice?
So part of that, when I say data is king, I'm actually quoting a statistician named David Hand, who I would see speak years ago, and he was fantastic. He head up the Royal Statistics Society in Great Britain, and he's written a ton of books. And I was very fortunate to be able to see him speak live in person. But that's contrasting with statistical algorithms. Like the classic approach to statisticians take is we would say the model is king. So the algorithm is what you focus on, and the data is used just to confirm a hypothesis or reject a hypothesis.
Mhm.
But you're really thinking what model? Think of like a linear regression model where you're just combining a bunch of observable things and to try to predict some outcome. In the machine learning world, we say data is king because the models are usually what we'd say induced from the data. So that means there's no predetermined structure or predetermined way the model is supposed to interact with the data. It learns it. So a decision tree determines what splits it's going to make when it builds that decision tree from the data itself. That means that it's wonderful because it's flexible, but it's also extremely dangerous because the data completely objective. We have to select the data that's used for the models, and the algorithms don't have any common sense. So they don't know. Like we can look at the data and see, oh, here's somebody this is a 155-year-old donor because their birth date, look at the birth date now, but then they gave $100 last month. Now we look at that and we'd say, "Ugh, that's garbage, of course. So let's ignore that." The algorithms don't know that. They're like, wow, very cool. 150, that's a really old person, and it just uses it without even like quote unquote thinking about it. So we have to be very careful when the data is king. As powerful as the idea is, we'd be very careful that the data is correct, consistent, and reflects operationally what the business cares about. So the data is king concept is really important, both on the positive side, which I love. Also on the negative side, that we've got to be really careful. So a lot of what I do as an analyst is trying to identify where the models could be deceived by the data. And so you run a bunch of diagnostics, data audits. You look at unusual cases, predicted cases that are oddball kind of head scratchers. Why did it miss this? Why
Hmm.
did it not find this fraud case, which is so obvious to a person? Because it's only the data, the observable things, what characteristics of the consumer or the tax return or that Navy SEAL candidate we know, and try to associate that with that outcome that we most are interested in.
Really impressive. At Techsalerator, we deal with data quality at scale, always doing business data across hundreds of countries, constantly changing, constantly cleaning. You've called data cleansing, tedious and never ending, but critically important. How do you think about the trade off between perfect data and shipping something that works?
Yeah, it's data cleaning never ends. And it is not, to me, it's not a lot of fun. But I think it's critically important that the engineers who are doing the data cleaning understand something about the algorithms where those data elements are going to be applied,
Hmm.
because algorithms handle bad data. By bad data, I mean maybe outliers or unusual values of some kind or missing values. They can handle them sometimes easily, sometimes not at all.
Hmm.
But the way they interpret that kind of data is different. So we have to have some idea of how we want to change the data to match better with what the algorithms do. Now, from the perspective of perfection, I'm glad you worded it like that, because one of the dangers that data scientists, the trap we fall into, is we can see, I can get this data up to this point, or maybe up to this point. If I just spend a little more time cleaning this or fixing this, or there's another feature I'd like to build. And that's where the good can be the enemy of the best, where by trying to achieve perfection, there's an opportunity cost associated with that.
Yeah.
From a business, this is why the business is so important in this process. What we want most of all is to put this model in place to be operational in the business, to solve some kind of problem, to make the business more efficient, identify more leads, or whatever the purpose of the model is. And we want to do that as fast as we can. That's better than what we're doing now, so that the business can benefit from the analytics. And that's the problem with perfection, is then you're delaying, you're delaying, you're delaying, you're delaying. And meanwhile, that opportunity cost is biting the business. So it's difficult. That's one reason why we need to understand in that contract between the business and the analyst, if we achieve this level of accuracy, will that be helpful to the business? And if it is, let's hit that waypoint as soon as we can, make the model operational so that the business can benefit. And then, if there's time or if there's sufficient ROI associated with improving it, we can go back while the model is running and
Yeah.
improve it. The other
Yeah.
thing that's beneficial there, one of the big ways that models fail is operationally things happen that we didn't know, like the ML ops, or how the model gets put into production, whether it's or data in the database that we've got to reconstruct in order to run through the models, all those kinds of back end things that happen after the model is built. And it's good to go end to end through the solution, even if you're not operationally running it, if you're simulating as if you're running operationally, just if all those things that go wrong. Because I've seen projects delayed for months because something was assumed that wasn't available, like a database wasn't available, or data that we needed to stitch together with our modeling data is not available readily. It's only updated monthly and not weekly, or something like that. It's hard to track all these down. It's good to run the model process through end to end to identify those before you get to the critical part of production.
Yeah, nothing is ever perfect in my
Right.
opinion, data wise or not. But yeah, that's a very very interesting point that you make, and it can be relatable to so many other things, and that's why I've been appreciating so much this conversation today. Thanks again, Dean. Anyways, talking a little bit more about the AI, the hype, and everything that's going on right now. So, LLMs have made it possible for people with no data science background, me as an example, to do things that used to require years of expertise. Is that mostly a good thing, or does that scare you a little?
It's a double-edged sword. So a workshop I just taught in San Francisco a week ago was on auto ML. How do you automate machine learning? and auto ML with Gen AI using these LLMs. The good thing about it is the day before I changed how I wanted to do the workshop the day before. I was thinking, no, I want to do this instead. So I used LLMs like Claude or ChatGPT and I prompted it so that it ended up creating 6,500 lines of Python code. Now I'm a reasonable Python programmer, not a great one. I know other languages. I mean, I learned so many programming languages. I got sick of it. Oh, Python came a little bit after my deep dives into all these different programming languages. So my Python's not great. 6,500 lines of Python code the AI wrote for me that worked and that I could just run through the next day with the students in the workshop. Phenomenal. However, I would not have been successful in doing that if I didn't know exactly what I needed as the outcome. So that's a double-edged sword. If you are an expert in the field or if you're knowledgeable in the field, like a senior level data scientist, you can use these LLMs to, write code, write front ends for you, do a bunch of the analysis, write the Python code to build out a complex analysis. Because there's some things that I did in the workshop that I'd never put in code before. Some ideas I've had through the years that I've never written the Python code to do that I've always wanted to. I said, let me just try it. And it worked. It was great. So that's really cool. But it made mistakes along the way. It misinterpreted some, or I didn't explain things exactly right. And that's
Mhm.
to me the danger. So you can have LLMs do like junior level data science or data engineering tasks, and it does it quite well. But it doesn't know when it gets it wrong because number one, they're supremely confident about whatever they do. And I'm using they as a pronoun instead of it because I just do. But so they're always supremely confident and they're always supremely affirming, always telling you how good you are, what your question, your prompt.
Yeah.
So because of that, I mean, sometimes I'll ask it to red team it, to critique what it does, or I'll use one LLM to critique what another LLM has
Mhm.
generated to try to refine things better. But they're limited in what they really understand. So because of that, I think they're most effective in the hands of more seasoned professionals who know more about what the project they're trying to complete are than it is for an entry level solution. I would never use an LLM standalone, completely automated for a mission critical task
Definitely.
because they don't understand enough about where they could go wrong. So that's a two-edged sword. So my biggest question, the question I ask business professionals everywhere I go now is how do we develop senior level data engineers or data scientists in a world where some companies are saying we don't need the junior level people anymore. We can just use AI to do this. Because, the Malcolm Gladwell book on, I think it was in Blink, and he talked about the 10,000 repetitions to achieve, expertise in something. I know from my career, one of the most helpful things I did was have to do the same kind of thing over and over again. So it's kind of boring, but you learn nuance and it becomes what we would colloquially call muscle memory. So
Mhm.
I played a lot of sports and you want to get to the point where hitting or shooting free throws, like one of the drills we do playing basketball is you shoot free throws with your eyes closed because it should be at the point where you don't need to see it anymore. It's the
Mhm.
same motion over and over again. The 10,000 repetitions becomes muscle memory and you just know it really well. We want to get our data scientists and our data engineers to the point where they understand their craft so well that they don't have to really think about it that much. You need a lot of the so-called boring repetitions to get there. At least I think. Now, could this accelerate you in that process? Maybe, but I think we have to think more carefully about how to train the next generation of technologists. Apply the same thing to attorneys, to all kinds of other fields, and HR also. Yes.
Absolutely. You need to start at the junior to get to the senior, and you need to be able to be bored. I think that's very big and something that is very rare in the latest couple of generations. People are just not very good at being bored because they can do a lot of this and a lot of
Yep.
that. So you need to be able to be bored at your job. Sometimes I'll be interviewing for the 20th time for a position and I already know all the questions at the top of my head. And then I need to be able to be bored with these questions, but also hop on the call and be like, okay, this is a subjective human being and this is going to be a different experience. And then it is, and it always is. And sometimes I'm like, this was such a nice surprise. So, with
Because there's an
boredom,
interaction. Because you're eliciting feedback from, so your questions are standard, but
yeah.
because you know the questions so well, you can adjust them or pull out nuance that you're identifying, those patterns that you're identifying during the interview that you wouldn't have known in advance.
Absolutely. Absolutely. And that comes with patterns and boredom and all that. So, very cool stuff here. Now, to wrap up today, if you had to bet on where predictive analytics is actually heading in the next couple of years, I know these days it's very hard to predict what's going to happen in the next hour when it comes to AI data. Literally, the next 30 seconds, maybe Anthropic will come up with something absolutely insane. It always does. But, anyways, what do you think that that would look like if you had to predict right now?
Yeah, and so I usually tell a joke at this point that, I'm a predictive modeler, machine learning guy, and we live in the past. And we assume that what happened in the past is going to replicate itself in the future because that's the data is only past data. And then we're making that assumption that it will replicate itself in the future. So I'm not really good at forecasting in general, but I'll play along and say a couple things. One thing I do think that AI and the LLMs have sucked the oxygen out of the room for now. Machine learning and this style of analysis is still, I would say, operationally, that there are far more projects that benefit from this kind of analysis than generative AI, though there certainly are good generative AI use cases. But because it's sucked the oxygen out of the room and because of the hype, I mean, that a lot of companies are doing things to try to jump on the bandwagon, the whole fear of missing out phenomenon that they're trying to do. So very few projects are succeeding right now as companies try to figure out exactly what they need to do. So I do think there's going to be an adjustment with AI in the next year or two. Like I'm not in the camp that thinks that, 90% of jobs are going to go away and all that AI is going to do everything. Because I think like what we're seeing in the legal profession, talked to someone the other day about how many legal briefs have been demonstrated to be false because AI was used and they generated false citations. And I see that also in data science where you'll ask to do research and the AI makes up a plausible but false inference about either about the data or about a study that was done. So I do think we need a new paradigm for how the LLMs actually work. That's different from what we're doing now. Maybe that'll take 3 to 5 years to find something new. I don't think
Mhm.
we're in danger of AGI, artificial general intelligence, where they will completely replace humans. I don't think that they'll ever completely replace humans
Mhm.
because I think our understanding of the human brain is very hard to emulate with the mathematics we have today.
Yeah.
At any rate, so I think that there's going to be this hype cycle. I think is going to shift. I think from a machine learning perspective, what I'm hoping happens, and I want to play a role. Now I've got enough gray hair. I don't have that many more years left doing this, but I want to help companies automate what they do so they can more efficiently and effectively, not just efficiently, but effectively apply machine learning and break away from the algorithm centric instruction that we get mostly and bring into it other parts of the analytics process that we all do. And that's my next book is about that particular topic that I'm in the middle of writing right now. Are what are
Nice.
12 things that really change the way we do machine learning that are important that are not taught in grad school. So that's the near term, I think.
I agree with you that AI won't replace all jobs, but I'm not gonna get political about, the types of jobs that will be replaced and things like of that nature today. But anyways, well, Dean, this has been so great. Nearly 4 decades of work in the field, and you're clearly still so curious about it, which is so nice to talk about it with you. And it comes through so easily because you're so curious and so interested. So thank you again for being in my podcast, our Conversations in Data podcast. If you guys want to take a look at Dean on LinkedIn, Abbott Analytics, everything we're going to link on the comments. And thank you so much.
It was a pleasure. Great conversation. I appreciate it.
Yeah, absolutely. Thank you again. And we'll talk soon. Maybe we'll have you again next year or even this year still. Thank you so much.
Be happy to. Thank you.